Hello and welcome everyone. Thank you for joining us today for our live Q&A session with the Zoo. My name is Ivan Trehin and I'm on the marketing team here at H2O.ai. I would love to start off by introducing our speakers today. Philipp Singer and Dmitry Gordeev are senior data scientists at H2O.ai, and John Spooner is EMEA head of artificial intelligence at H2O.ai, and he will be leading our conversation with the Zoo today. Before I hand it over to John, I would like to go over the following housekeeping items. If you have any questions for the Zoo, please use Slido to send them to us. Just go to slido.com and enter the event code ZOO. You can also use this link to upvote some of the existing questions and make sure that we answer them. And this session today is being recorded. A copy of the recording will be available after the presentation is over. Without further ado, I'd like to hand it over to John.
Thank you, Ivan, and welcome everyone for this hour webinar. Kaggle is an online community of data scientists and machine learning practitioners, which allow users to find and publish data sets, explore and build models, and then work with other data scientists and machine learning engineers to enter competitions. Those top Kagglers, of which there are only a couple of hundred, are known as Kaggle Grandmasters. And it is my privilege and honor to be able to chat to two of these who are collectively known as the Zoo. As Ivan said, the Zoo is made up of Philipp Singer and Dmitry Gordeev. Over the next hour, I'll be chatting to them both to really help understand the world of data science. As Ivan said, we'll be using the facility of Slido to really try and make this session as interactive as possible. Do bear with us. There potentially could be an audience of nearly 300 people, so we may not have time to answer all your questions, but hopefully you will be able to interact through the upvote and getting questions that you have a real specific interest in up to the top of that list. Who knows exactly where the conversation will go, but I would imagine it will probably touch upon some of the following areas. We'll look at the Zoo and their background, their advice for data scientists out there, specific topics around Kaggling. We'll probably touch on some data science methodology and then move into industry and data science. So welcome guys, hope you've had a good weekend. Just a quick question, the most obvious question, I think Dmitry, you're the one who answers this the best. Where does the name the Zoo come from?
Yeah, thank you. That's the question I usually answer. It's kind of a simple story because we started competing on Kaggle while working together for a company in Austria, and back in the office we had a bunch of virtual machines we're using for the business needs, and we started naming the machines just not to memorize all the IP addresses, and we named them after animals just because every package we used was one way or another, usually like animal related. If you do Postgres, there's an elephant there. If you do GitLab, there's a fox. So the naming came quite easy. And at some point, Philipp started like putting pictures of animals on the wall with the IP labels of the IP addresses. So by the time we decided to start a Kaggle competition just to see how well we're doing, we had to like punch in a name. We looked around and like saw the animals around, like, okay, let's type in the Zoo or whatnot and proceed. Fortunately, it was not the smartest or the most creative name. And fortunately or unfortunately, the first competition we attended, we won. So it was a clear sign that we have to stick to the name now. And we just rolled with it.
Excellent. Well, it's a fantastic name and something that you are known throughout Kaggle as. So Philipp, a quick question to you. What got you specifically interested in the field of machine learning?
It started when I was at university. I was just finishing my bachelor degree and started my master's degree in computer science, or rather in software engineering and economics was my studies called. And it was then that we had some kind of different areas to choose in the master's studies, and one was more related to data science. At that point in time, it was not really called data science. It was a little bit more related to more machine learning, more information theory, so these kind of things. And then I got basically involved in an institute that was focusing on these tasks, started my master's thesis also around that topic. I did some kind of Twitter analysis at that point in time, so crawling data, analyzing data, building some kind of machine learning models, doing sentiment analysis, these kind of things. And that got me quite hooked at that point in time. Finished my master's studies, decided to do a PhD, also evolving around that topic. And that basically got me into the field. As I said, at that point, we didn't even call it data science, I would say. I think that term kind of emerged only a bit later that people started to talk about it. But it was definitely evolving around the topic, and since then I'm focusing on that.
Excellent, excellent. And Dmitry, where did you get your spark to learn this area of machine learning and data science?
Even back in university, I finished Moscow University, and we had a separate department. It was called data mining, more or less, or like for mathematical forecasting. I got interested in the topic. I went there. Then I switched to a career in banking industry for quite a while, and now I'm back to more general machine learning topic as the one which sparked me in the first place.
Excellent. And then you discovered Kaggle on your journey of data science. So how long have you been competing on Kaggle for?
I started like 5 years ago, probably. I took like a couple of competitions. Then I realized I don't have enough time basically to do well there. So I can put some efforts, but it might get more disappointing because if I would have put more efforts, I would gotten probably a little bit better result. So I kind of put it on hold for a while, and then kind of the second wave, we started competing together 1.5 years ago, and we're quite active for this 1.5 years until now.
Okay, awesome. And looking at Kaggle, Philipp, then what do you think makes Kaggle so special as an environment to work in?
First of all, it has an amazing community, and there are so many talented people around the topic that interest me and interest us. So that's always a very nice place to operate in. If you can communicate with others that have the same kind of passion about something you really like doing. So I think that's one of the main things that makes it special. And the other thing is it really gives you a nice environment to work on things that you're usually not able to work with. So you have a lot of competitions, you have a lot of different business problems, you have a large diversity of different topics that you can get in touch with. You can really work on the edge of machine learning by trying out new techniques, doing state-of-the-art methodology. So it really gives you a place to kind of be creative, kind of really follow your passion. And I don't think this is always possible in your day-to-day work. Not everyone is fortunate enough to work in an environment where he or she can really work on all these interesting problems. So I think it's a very nice place to do that.
Well, that's really interesting that you say that, in the fact that one of the questions that we've got is, for a data scientist, what should be their priority, learning from office work or learning from Kaggle competitions? But from what you were saying there, Philipp, it seems to be actually you can blend the two and one will enhance the other. Would you agree with that?
Yes, totally. I think both are very, very valuable and important things for a data scientist. I think a data scientist is usually, and that's my personal opinion, is usually also someone who has to do a little bit more things than just doing the modeling, specifically in companies that don't have like super large artificial intelligence departments. But if you just work in a company that is getting into the field, you have to probably also do other things. So on Kaggle, you can really focus on the modeling aspect, and that's a very, very important part. And you can also as I said, get in touch with state-of-the-art things that can really improve your modeling activities at work. And also what you also learn on Kaggle is how to properly validate things, how to not overfit, how to think about which kind of models then also are the ones you choose in the end. And that's also what you need to do at work. If you want to put something into production, you need to choose a model in the end. Yeah. But in an office environment, you learn many other things. You learn talking to business units, understanding their business needs. You probably even learn about how to build an API around a model to put it into production. You're rather more involved into the whole lifetime cycle of data science problems. And on Kaggle, you really go deep dive into some aspects of this cycle.
Excellent. So Dmitry, without giving away your secret sauce and those trade secrets that keep you top of your game in Kaggle competitions, is there anything that you can share with regards to how you approach problems on Kaggle? Is there any kind of methodology behind your work?
Maybe only like a very vague and high level one, because we try to, whenever we pick a new competition, we try to do something we haven't done before, something different, either topic wise or data wise. So we try to find the competitions which will not just be a repetition of another one, of the previous one. So there's no like strict guidelines of what we do. And the best and most enjoyable competitions are those where we get the data which looks very strange and new to us, and we spend first weeks just exploring it and trying absolutely random things. Because this is the most enjoyable and fun experience, to try something completely new and different and see how it works, and hopefully see how it beats something which would be like the out of the box things there. But the typical things we do, the things we always do, is start with setting up a robust way to assess your model, and proceed with experiments. Basically, probably only these two steps remain for all the competitions. And it's not that it's changing. Usually we set up, okay, this is a way we do cross-validation like this, it works well, we check it. Usually a few weeks after that, we're gonna change it. A few weeks after that, we're just gonna redesign it again and start over.
Okay, so you've got a sort of high-level methodology that you go through, and there's certain things that make you really tick in terms of a favorite competition, so things that are new. But if you were to look at, both of you, your favorite competition of all time on Kaggle, what would it be? You probably entered tens and hundreds of competitions. So Philipp first, what would your favorite competition be?
I think both of us will answer the same thing here, which was the NFL competition, Big Data Bowl. It was about predicting how many yards a rusher will run, how far he will get. And it was about having tracing data of movements of the players within a play in American football. So you had like the coordinates, and you had like the speed of the players at the time of handoff, not going too much into detail here, and you needed to predict how far the runner will go forward with the ball.
Okay, and Dmitry, would you agree with that?
Absolutely, 100%. That was by far the most untypical and fun and quite well organized competition, because the sponsor, NFL, was very active, answering questions, providing feedback, and the competition was well structured. There were no like hiccups on the way, and it was like a quite an unusual data set. And yeah, in the end, we had an interesting creative idea, and it shined. So we enjoyed the whole thing from the beginning to the very end.
And how long did that competition last for?
2 months, I think. Well, 2 months for the competition and 1 month to assess, because they also did it in kind of a very fair way. We supplied the models, and then they were recording new data from the actual games for another month. and applying the model to the actual games and assessing how well it predicts.
Okay. And I'm pretty sure, Philipp, during that competition, there were times where you were frustrated and you got stuck. How did you proceed further? What did you do? What were your approaches when you felt you were at a dead end?
That's a very tricky question, because of course that sometimes happens, or frequently happens during competitions, that you're kind of at the dead end. I think one thing that really helps here is teaming up with others. So you can first of all explore different paths, and even if one of you gets stuck in a dead end, the other might explore some different path that leads to a better place. So having diversity in also what you try, and what is also very important in these settings is that you report to the other persons on your team whatever you're doing, so that they don't take the same path. But otherwise, it's just trying out ideas. Having a large backlog of ideas during competitions is usually good, because then if you're stuck with some idea, you can just go to the other one and try it out. And it's not easy to say, but don't try to be frustrated, because yeah, that's science, right? You explore different things. Some things fail, and the more fails, you will get to a maybe nicer solution. There is a nice quote I always like, which is something like R and R and R, but less and less and less. So make errors, but less errors, less errors, less errors. So get to something that then improves your solution. And yeah,
and that's a really good point. I think data science is all about iterating through a number of steps, either iterating through engineered features, iterating through model algorithms, or hyperparameterized around that. And the case is, as you say, how do you iterate through that process as quickly as possible? So Dmitry, clearly there's a whole range of different things you can do to win a competition. And one of the key things is the algorithm that underpins your solution. And there's more and more algorithms coming out of academia. So how do you stay aware of all of the new AI algorithms that are coming to bear?
Thanks to Kaggle, basically, that's the way, that's the place where people share what they did, what worked on the past competitions, and sometimes quite frequent in the current competition as well. And it is a very good place to try out things on your own, try out new things. So with regards to the methods which are quite recent and out there, you can quite easily usually just try it out, compare and benchmark to more typical ones. And another way is to go through the forums, go through the past competitions with similar data sets, and just see what worked, what didn't work. And usually if some new idea really shines, then someone from the past competition would have like picked it up, used it, and if it worked, then you would have seen it. You can see it now in the winner solutions. So it makes sense to just like browse through similar things, similar problems, pick up the ideas and try them. Even sometimes the ideas which kind of not fully failed, but not really worked super well in the previous competition, might be like more applicable to the one you're working on. So like just going through what people did, and people share a lot on Kaggle, so you can learn really lots of ideas and techniques, and they are state of the art for those problems at this moment. So you can be sure that there is barely anything better for this one problem at the moment there.
Okay, so really, as the competitions then evolve, the good AI techniques then are in the winning solutions, which enables you to then keep on top of those techniques. Excellent. So Philipp, on the call, we've probably got a number of beginners in the world of data science and also within Kaggle. So what advice can you give them to become top of their profession and become a Kaggle Grandmaster?
I don't think there is a secret sauce that will make you Grandmaster. I think it's just that you need to keep on trying and don't be afraid to fail. It's always easy to say, but there is no shame in getting last in a competition. It doesn't really matter. You learn something, you got something out of it, and that's very, very valuable. We are living in an information and in a learning society, so make use of it, learn from others, keep pushing, and at one point the results will kick in. And yeah, as I said, just keep going. And as Dmitry said, there is a lot of valuable information out there, also from other solutions, from previous competitions. During a competition, there is so much shared that can push you forward. You need to read actually a lot of the discussions. You need to check the kernels, make use of this information, and then you will succeed. I'm sure of that. So just keep on pushing.
Okay, excellent. So obviously we've seen a big rise in the popularity of data science and leading into artificial intelligence. And at the heart of that has really been the increase of availability of compute. Clearly, you've got now cloud compute, and underneath the covers of cloud, and also on premise, you have graphical processing units to accelerate the task of building models. So there's a question here with regards to GPUs being required for Kaggle experts. So how many GPUs are required for Kaggle experts, Dmitry, and which GPU do you specifically use?
The truth here is I don't own a GPU at all, and out of the 3 competitions we've won, I think for all 3 we did not use our own hardware, and Kaggle hardware was sufficient. And that's kind of a message to people out there who believe that they don't have enough hardware. I truly believe a very good idea beats any hardware you're competing with. Of course, it's not always true, because if you go and try Google computer vision competition, where there are like hundreds of gigabytes of pictures out there, you have to use some GPUs, and probably you won't be able to like process all the data with only Kaggle resources. But there's always a couple of competitions out there where you don't need it to actually succeed.
Okay, and if we break up data science into those areas of feature engineering, algorithm selection, and post modeling, and think about first of all feature engineering, a lot of the time you really get the extra accuracy of a model through advanced feature engineering. So Philipp, have you got any go-to techniques for feature engineering that you specifically always look at to start off with?
Not really. I think, again, there is no kind of secret sauce. It's rather you need to do a lot of explorative analysis on the data, and through that try to identify which kind of patterns in the data can be predictive for the target, and then try to get around that and develop features. It's also usually a good idea if you try to read a bit up on the business problem, read a bit up on the topic, because usually if you would in an office environment, the business can help you, for example, a lot with feature engineering, because they understand the problem, they understand hopefully even the data. And in a similar thing, it sometimes works in Kaggle competitions to read up on the topic. But I don't have any kind of secret here for feature engineering. I think lately also the trend goes a bit towards the direction to let the models do more part of the feature engineering. Models get stronger, people get more creative in designing neural networks that can kind of already do certain types of feature engineering on their own. But of course, it's still very important, and specifically in tabular competitions, feature engineering still plays a huge role. The most important thing is to get the solid cross-validation setup and then iterate through your feature engineering ideas and get a feeling what works and what not.
Okay, so once you've got your model, and this is where there's probably a crossover between the best model with regards to a Kaggle competition and the best model in terms of pushing to production. If you think about the work that you've done in industry and specifically in your role at H2O, how did you decide whether you've got a best model which can be pushed to production? What are the things that you think of when putting it into production, Dmitry? Maybe, yeah, have a go at that question.
The very first thing I would recommend to think of is the ways to assess the model. So the very first thing you probably should do is to define a way how would you assess which model is better than the other, and make sure it's a good, robust way, make sure it's a good evaluation, so you trust it fully. So if by means of the procedure you defined, one model is scoring higher than the other, then you fully trust that this is how it should be, and you would trust like the higher scoring model than the lower scoring in production. And after that, I think benchmarking is something which can make you confident with the model you have. Because if you just find an article that like a specific types of neural networks work very well on certain types of data, you implement it, you get a metric, you get a value. Usually it's quite hard to interpret whether it's a good value or not. So try to approach it with like different modeling techniques, try simpler models and so forth. This would make you realize how big a leap in the accuracy would you gain by switching from simpler models to more complex models, and by using different techniques among more like enhanced machine learning techniques. And then you can easily decide on what is best for the production. So you see how much price you pay for how much extra accuracy you gain by switching from a more from a simple standard approach to a more heavier one. And this is where you can in a straightforward manner draw the line. Okay, this is the accuracy I'm happy with, let's minimize the runtime, or the other way around, let's squeeze as much as we want, as much as we can, and pay the runtime. Then let's go for the best model out there according to our benchmarks.
And I suppose this is where there's the human aspect of understanding more about the business problem, in terms of there's probably always going to be a balance between the accuracy of the model and how quickly that model can be put into production and then executed as well. And it's interesting that you talk about sort of a concept that I see as a value add. So what's the value add of making a model more complex? Is there actually business value with regards to that? So Philipp, one of the problems that you have, I think, in data science is sometimes a challenge with regards to a very high class imbalance, both from numerical data and also textual data as well. How do you handle specific problems with high class imbalance?
Yes, that's an excellent question and a very tricky question, because again, I don't think there is anything that always works in this case. And again, I can only repeat myself. It always depends on the business problem and how you define your metric. If your metric is about ordering or your business problem is about ordering the cases, then you would probably address this differently compared to if you want to say something like, oh, I want to have all my minority class in the top 100 of my predicted cases or something like that. So you always need to think what really is your business problem, what really is your metric, and how do you want to address this. There are, of course, plenty of techniques out there to try to get a few more digits out of the metrics in case of imbalanced classes. Things like just overweighting, underweighting, different sampling techniques, things like focal loss in neural networks, so different things. And to be honest, we usually try them, and they are not always that promising. So again, there is like not one solution that can help you with this. I think a good model can already pick up on it. What is important also sometimes is to get things like, again, talking about production, is to get interpretable results, so get something like calibrated probabilities, then you would maybe calibrate the probabilities afterwards. Yeah, but it is not an easy task to solve, but usually I think it is also a bit overstated, the importance to do something upfront. I think the models usually are quite capable of addressing these issues on themselves.
Okay, a lot of what you've both talked about is trying lots of different things and potentially failing faster. And obviously, as you gain more and more experience in Kaggle, you know which techniques to try. So Dmitry, a question for you is, how do you look at automating some of those steps that enable you to tick off all of the quick wins first of all, and then start to spend time on the value add? How do you look at automating the process?
Actually, it's something we don't do that much. So we try to save like certain things we've done in the past and which worked over a couple of competitions, and then reuse them, but we don't do it that much. Though we've seen other successful Kagglers do that. So they have automated like libraries for feature engineering, automated procedures to do one thing or another. That actually helps a lot to get into the problem, to have a quick and good solution. But in order to squeeze like the necessary digits to get to the very top of the leaderboard, you need to customize it always, either to the data or to like certain structures or to adjust CV. So there are always some handmade adjustments you need to do. And therefore, like completely packaging it and automating everything, it can work, but not as good as manually customized solutions to these tasks. So we usually start by exploring, like playing around and building it like bottoms up, basically. So from scratch, but like reusing some pieces of code or some snippets from the past competitions. But maybe it is something we should actually improve in the future, to have pre-packaged things to maybe speed up this process. So start not from very beginning, but start from like a very typical thing. So a bunch of like feature engineering for time series, usually done with lags, leads, and differences, and then build on top of that.
Excellent. So just one question that's been at the top for a while. Is there anything else in terms of Kaggle competitions that you can get out of them? So obviously you get different algorithms, you look at feature engineering, you look at post-modeling analysis. Is there anything else that the audience can get out of Kaggle competitions, do you think?
To me,
So,
I think the most valuable thing that a lot of people undervalue is evaluation. This is something that you learn on Kaggle the hard way. You really have to get and do proper evaluation of your model, do proper cross-validation. Think a lot about the problem, how different cross-validation techniques work. Is it a time series problem? You do something differently. Is it a tabular problem? Is it like some other types of issues? You don't use the same type of cross-validation all the time, but you learn really through failing and through hard work what kind of techniques work in what kind of situation. And I think this is something very, very valuable that can already bring you a large leap in your company, in whatever you do outside of Kaggle. Because coming back to this problem of what to put into production, if you have that figured out, you will have a way easier time also to decide on the models. And if you consistently on Kaggle select the top private leaderboard selections, you have done something right out of your list of selections that you can select in the end. Because then you have understood the problem, and yeah, validation is something really, really crucial. And this is also something that I have observed in the past that many people do wrong. And this can lead to really bad problems. Like if you overfit on your validation set and you claim, oh, you have 99% accuracy, and then in production, this model completely fails due to logical reasons, this is not something that you will be happy with. So I think that's one of the main things that you can learn on Kaggle, and you should really do that.
Yeah, on Kaggle, you get kind of punished for not doing things properly and fast, because you get checked against the test data, you get compared to other models, and if you do something wrongly or you do something not the proper way, you see the results immediately. But if you do it in like a business environment, you usually, well, you always don't have someone competing with you to build a better model for the business case. So if you make a mistake, you will only see it when it's too late. And on Kaggle, fully agree with Philipp here that the key lesson is to learn how to do it properly by means of having it benchmark against the others. But that's not all you learn from there, because if you look in kind of a more broad way, you see how business tasks are being shaped into machine learning tasks across the industries. You see how data is being collected, what data is being collected, how it works or how it fails. And if you look a little bit like outside of just the numbers on the leaderboard, you also learn like the drawbacks of the models, or the ways to potentially improve them, or the ways to potentially improve the setup, or why the setup was like this or not the other way around. That helps a lot in the business. And last but not least, also a good example of NFL we mentioned. NFL provided this data about tracking players on the field to quite a large community for the first time, I think. And it was kind of a new type of, a new structure of the data, even for those who work in analytics in the clubs. So sometimes you don't even know how to start with this data, and you might end up like just generating the usual tabular features and try to make sense out of it, though there might be better ways to work with the data at hand. And Kaggle helps you to learn that aspect as well. So it is not that like typical and automated, you generate features, you apply LightGBM or XGBoost and you win. Sometimes you have the data which cannot just work this way. Another thing is like a lot of industries work with tabular data and quite afraid of using like texts or images or any other data structures they have. But on the other hand, when you go to Kaggle, like these days, I think more than half of the competitions are images, and you see those models are working surprisingly well. And you start thinking that it might be a good idea to bring new data types to the business problems.
So that sort of rounds off quite nicely the Kaggle bit and some of the experiences that you've got. And I can't believe we've gone 40 minutes into this particular webinar and not really touched on technology at all and what technology you utilize. So top of the list now is, what technology do you use? Is it PyTorch? Is it Keras? Is it something else? Is your tool of choice? Philipp, what's your weapon, so to speak?
So first of all, let me say that use whatever you feel the most comfortable with. There is not, if you like Keras and people say PyTorch is better, you don't have to use PyTorch. If people say the one package is better than the other, you don't need to. There is, like, I think all of these tools today are very close to each other in terms of functionality, and it's about you feeling comfortable with it.
I
That
imagine
said,
efficiency as well, not just confidence, but efficiency of the data scientist as well.
yes, totally. So that said, I think both of us are rather PyTorch guys nowadays. When we started on Kaggle 1.5 years ago, we started using Keras, and then at one point we started moving to PyTorch. At least to me personally, it allows me to a bit quicker to iterate. But again, that said, I think both are very close to each other. They have only tiny details. In our recent competition, we actually rather used Keras compared to PyTorch. And there are sometimes even there is a benefit of using both to understand the problem. For example, just finished yesterday the ION competition. Keras model was consistently outperforming the PyTorch model, even though the structure of the net was exactly the same. And so we digged and found like that Keras is initializing some random weights in the beginning differently to PyTorch, and that alone caused the difference. And again, this was valuable because we understood what is important to tuning these models. It's easy to then take the PyTorch model and change the initialization, but this just tells you that exploring different things again is very, very important. But that just stick to whatever you like. I don't like this wars, PyTorch versus Keras. There was also a lot of discussions lately on Twitter about that topic. On Kaggle, it's a regular topic. I think both are very similar nowadays.
Okay.
I formulate the same answer a little bit differently. I would say PyTorch right now. A year ago, I would say Keras, but in half a year, I don't know what I'm gonna say. Maybe it's gonna be Keras again. Maybe it's gonna be something we don't use yet. But my point is be open to other technologies, libraries. Explore. Don't get frustrated if you use Keras only and people say PyTorch is better. Try it out, see what's better, what works better for you, and stick to that. This is, I mean, I personally started with Lasagna, which was a package in Python like 3-4 years ago. People used, then we used Keras, then we tried PyTorch, we liked it more, we switched to PyTorch, and in half a year, there's a good chance we're going to switch to something else.
Okay, and thinking again of your role at H2O, you spend a lot of time doing R&D type work, but also work in industry as well. If you look at the work that you're doing, where do you see the industry, which industries do you see to be impacted by artificial intelligence and machine learning in the next 5 to 10 years? Philipp, what's your view on that?
All of the industries, I would say. I think it can play a role everywhere. Even a small shop owner somewhere can get a value out of just very simple data science techniques, understanding the customers, trying to improve on a few things. I think in general, our society is nowadays quite aware of data and its value and all the issues around it with privacy and so on. But there is still so much untapped potential of utilizing the data for good things, either for your business, for social goods, for other similar things. So in general, I would say really all areas can have a benefit from it. Maybe if I would need to make a guess of where really a shift can happen, it's probably the service industry. I think a lot of jobs are not really necessary and could be maybe replaced or not replaced, or rather supplemented by AI techniques. But for that to happen, you also need to start bringing people into different educational paths in order to then shift the society. So it's not an easy thing to plan for.
Okay, so there's definitely further work to be done in the application of machine learning in business. So the role of a data scientist is going to become, I would imagine, more and more valuable. But what do you see, Dmitry, as the future of a data scientist job? What do you see the key challenges being and key solutions for a data scientist in industry?
I have my own picture of what I want the future data scientist job to be, and I'm hoping this is how it's going to evolve. But I personally believe that it should be a way larger profile with a larger variety of skills. So I don't see this job as an enhanced or renamed data analyst. This is a person who should be aware of the machine learning techniques and the ways to properly apply it, as well as a person who is interested in the business topic he's working on. So he should be aware of what to do with machine learning, how to apply it, and to figure out the ways of how this can help in the business problem, basically. Besides that, I think he needs to know a little bit more about the setup, so a little bit more technical details about how this model is gonna operate, how to properly productionize it, and so forth. But the key message for me here for the data scientists: don't be more active, be more proactive with regards to presenting your solutions to the business people, because they're not aware of what machine learning can do here. But you can quite quickly catch up with the basics of the business processes behind, or the important processes in larger companies which can be improved. And you are the persons who can actually bring these ideas and bring them to life in the end.
Okay, Philipp, have you got any views on what the future is of a data scientist?
I mean, the mission of H2O is to democratize data science, right? So I think the future is that, as I said before, that a lot of people have basic knowledge in data science that doesn't need to go as far as fitting a neural net to image classification, but just some very simple statistical understanding of what you can do with data and what data is. I think that's very important, similar to as it is important that people learn more about programming in general. The future of a data scientist is, I think that, yeah, I think it's still a very promising future prospect of a data science. I think there is so much still to explore, so much still untapped potential. Maybe new kinds of data emerge. Couple of years ago, we would not have imagined what we can do with text and images nowadays. This will go even further, and maybe we can also explore new types of data. Even I can't name one for now, but you never know what is out there. I think it's still a very exciting job, exciting profession. We as data scientists will play a role in companies. We will play a role in society even. I think there is a lot of very good discussion happening nowadays about credibility of models, privacy of data. So all these things are also important as a data scientist to be aware of, and we need to also shape this up in future. So I only have good hopes for all of us in the future.
So it sounds that the skills of the data scientist is very wide and very varied. So thinking of you two working as a team, do you have specialisms that you go deep into while working as a team? Or are you deep in all areas of data science? Dmitry, what's your view on that?
Here, as we mentioned before, we're trying to jump into the new topics for us, because for us, Kaggle and data science in general is the place to learn new skills and new like become aware of new topics. And therefore we don't have like strict separation of who is doing what exactly in team. and everyone is jumping into the idea he believes is most fruitful for the moment and just tries whatever random things he wants to try. This is for us most fruitful because we're trying non-typical things, we're learning things, we're not getting bored by doing the same thing over and over again, and we share the findings. That also helps to like shape up bigger ideas, because if one is specialized in, you name it, neural networks or feature engineering, your exploratory analysis, your experiments can actually bring up a larger idea, which will lead to change in the cross-validation or change to a different type of the model, or completely redefine the setup of the task and so forth. So we prefer not to limit ourselves in any sort of way. It might end up being the case closer to the end of the competition, where we have a very clear understanding what works and why. So we know we have to focus on 2 areas and there is nothing else out there. Then probably we split just to make it more efficient.
Okay, and also with it, talking about industry, one of the big challenges that I face when talking to future customers of H2O is establishing a trust both in our technology, but also a trust in artificial intelligence to automate certain types of decision making. So when creating complex features to go into a model, how do you specifically maybe convince stakeholders that that methodology or that feature is useful for that particular business problem? So, Philipp.
Yeah, I think that's a very good and general interesting question. First of all, you don't have to go to the stakeholders or the business saying stuff like, oh, look, with this feature I can completely make your work redundant. Yeah, so it's rather, I think you need to go with the attitude towards these stakeholders that they can learn something from what the model has found. The business units usually have a quite nice understanding of their data, but they are also they are overfit. Yeah, so they overfit to what they exactly do. And they have very strong opinions about what matters and what makes sense. But with data, you can either prove it or not prove it. Of course, it's not easy to then convince them otherwise, but you need to go with the attitude towards them that they can learn something from it in order to improve their work. I have seen this happening before when we were working in insurance, for example. You tell people, oh, look, the model found this. Maybe you can also look at that when you do your work. And then it's like wow to them also to see new ways of looking at the problem. And of course, the more complex a feature gets, the more difficult that is. But nowadays, there are enough techniques out there to even make very complex features and complex models explainable, like we also use in driverless. We have a whole suite about explainable AI, and this is usually very valuable to then show to the business units. And it's not only that the model works better. I think a lot of this feature engineering and model importance and can really also improve the day-to-day work of business units. And you need to go with that attitude towards them. I don't think a lot of replacement, it's never about replacing people. It's rather go with the attitude towards them that you can help with models, their work, and then usually everything is more easygoing and you can improve.
Awesome. Thanks for that, Philipp. So Dmitry, obviously you are employed by H2O. So how do you work within H2O? How do you incorporate your ideas that you're probably finding on Kaggle into H2O technology or for H2O customers?
For the H2O technology, we're bringing the creative ideas we saw working on some of the competitions to broaden the ability of the driverless to better solve different tasks. Because for the automated machine learning, it is important to try out diverse ideas because this way you get the best results. And for the customers, probably the most we bring here is the experience with properly setting up the problem, properly collecting the data. So there's like a long list of the things which might be done wrong if you just collect the data, push the button, and expect a very good outcome. You need to sometimes you need to recommend to people to maybe reassess the business need, or maybe redefine the problem they're solving, often to make some adjustments to the data, like the target variable they're trying to predict. Very often it is better to change it or to adjust it, as well as the data collection. So sometimes it's something about way to structure the data, or maybe think of extra data to collect to solve this problem better.
Okay, well, we've just got a couple of minutes now to go before we wrap up. So I've just got one or two more questions. We've gone through quite a few questions. Again, apologies for those that have asked questions and we haven't answered them. But I'm sure we'll do reruns of this in the future time. So Philipp, here's a question for you. On average, how much time do you spend on a Kaggle competition?
A lot.
A lot. Good answer, Dmitry. What about yourself? How much time do you spend on a Kaggle competition?
It really depends. Like in last weeks of competitions, at least a couple of hours per day. I think you need to spend really quite a lot of time to get to the real top. Of course, you can get lucky, but that's not the goal. You want to have a robust solution. So, and we discussed about exploring all the different areas. So yeah, it takes a lot of time, and it is valuable time, but you can also get the good results, maybe not top, with less time investment.
Excellent. One question to you both, just to finish off, and just one word answer. So Dmitry, Kaggle is so popular now and the environment is more and more competitive. Do you think it is still possible to repeat your achievement?
Absolutely.
And Philipp?
Yes, totally. I mean, we started 1.5 years ago and it's still possible.
Excellent. Well, thank you everyone for attending this webinar. Dmitry, Philipp, thank you for your fantastic answers. And all I can now do is hand this over to conclude to Ivan.
Thank you.
Yes. Thank you, John, Philipp, and Dmitry for taking the time today. And thank you to everyone who joined us. We will share the recording of this session shortly. We hope you enjoyed hearing from the zoo today. We have many other events in the agenda, so stay tuned and have a great day. Thanks, everyone.